something that's called a piecewise function. So a piecewise function, you'll have seen this if you've done further maths from before, for different domain conditions. So there's two different domain conditions there. There are different functions that we need to draw, okay, or different equations that we need to draw. So we're going to draw 5 minus 2x. 5 minus 2x, remember, is just minus 2x plus 5. We're going to draw this sort of downwards negative graph for x values that are less than 1. So the first part of the graph looks something like this. And then when you get to 1, this includes 1, when you get to 1 and then greater than 1, there's some kind of quadratic, some kind of x squared plus 3 graph. So I don't know exactly, without going much further, if the quadratic is above or if it's below, okay, but it's sort of made in two parts. In fact, let's have a look. When x equals 1, where would they both be? So that one would go down to 3, wouldn't it? That would go down to 3. And I'm going to draw, sometimes you'll see like a circle here, which shows that it cannot take that value. So it goes up to 1, 3, and then what's 1 in the quadratic? 1 squared is 1 plus 3, so the quadratic's actually above it. And you can you can shade this bit in here to show that for 1, this would be the function that you look at. Okay, and it's going to go something like that. And these go off to the left and to the right. Okay, and this is a piecewise function. So let's look at a neater version. So a neater version, it's going to look like this. Okay, and I think we're doing something with the number 19 in a moment. So let's make sure we go up to 19. Okay, so what do we need to do? Sketch it and state the range. State the range. So let's start perhaps with what's the lowest value. So we kind of spotted already that this point here is going to be 3. So it's got something to do with 3. Did we say that we're allowed to have the value of 3 though? Well, we're not actually allowed 3. This is sort of a hollow dot, like from inequalities. So we'll put the 3 there, but this should be our inequality sign. Okay, so it can be greater than 3, and is there a limit? No, because the domain's going to go in the negative direction forever and the positive direction forever. So the range is just like this. Okay. Finally, solve f of x. So solve where this whole thing is equal to 19. So where are things equal to 19? Well, seems to be, sort of somewhere over there. So there's actually going to be two answers here. We can investigate first of all. 5 minus 2x equals 19. That's the point up here. What do we do? Take away the 19, add the 2x, so minus 14 equals 2x. So x equals minus 7, which seems to be what it is. So that's our first solution. Let's do the solution for the other part. So that's A, this is B. So for the other part, we'll just sort of stick this part over here. So it was x squared plus 3 is equal to 19. Let's write that again. It's equal to 19. So x squared is 16. So it's plus or minus 4. However, plus or minus 4, remember with the x squared, we're only allowed values greater or equal to 1. And I mean, our graph shows that clearly we're talking about positive 4 and not minus 4. So we have to ignore one of these answers. Okay, so it's x equals 4 as minus 4 is not in the domain. Okay, that's supposed to say as. So there we go. These would be our two solutions. So with modulus and also with piecewise, perhaps we end up with two solutions. Remember to be very, very careful with range and whether it includes values or it just sort of goes up to these values as well.